go over just one thing with that homework. But go ahead and put your grade on there. So we need to remember, right? We talked about it a little bit yesterday. In general, how do we calculate slope? Say it louder.
Rise over run.
Rise divided by run. All you got to do is graph your 2 points. Now there's multiple ways to approach this, and I only showed one of them. Notice I started here and I went down 5, so it was negative. Then I went to the left 3, so it was negative. And a negative divided by negative is positive. Notice, could I have also gone up 5 and to the right 3? Would that have given me the same slope?
Mm-hmm.
So you don't have to have exactly what I did, but you need to have the slope of 5/3. Same thing here. I went down 5 to the right 2. Could you have gone up 5 and to the left 2? Notice I've been plus 5 divided by negative 2. A positive divided by a negative is still a negative, right? So there's multiple ways to approach these. Linnea, put the pencil away, just that color pencil. If I see pencils out, I will just come by and put a 0 on there. You check your work. And it needs to be very clearly different than the pencil or pen you used when you actually did it. Otherwise, again, I assume that you're copying. I want to assume that, but also I want to keep the integrity of the class and of your grade. This is why you need to ask questions when we first start learning it. Alright, do we have our grades on there from today's homework? Put a date next to it, so that I know it's for today. October 2nd. 10/2, yeah. I laugh because I do the same thing where I'm like, I know it's a day of the week, but what is that day? Alright, let's get started. We're going to look at our objectives, and it's not actually just the set practice. We actually need to wrap up 1.7, and then we'll get to the set practice. I don't think we'll get to 1.8, but I have it in there just in case we get ahead of where I thought we would be. So, this is the same objectives we've been dealing with all units so far. It has not changed, because if you can identify and name the rate of change for a sequence, you know what's happening. Now I do want to point out, I erased all of this, but I wrote down the most important parts over here, right? What we need to think about with recursive equations, what we need to think about with explicits, the keys to arithmetic and geometric sequences. So if you need to reference that, it's over there. We also want to be able to create multiple representations of a sequence. What are the different representations you can always create? Tabular. Graphical. Say again. So a linear is a type of function. It's not one of the ways we represent those functions, though. Does that make sense? What'd you say? Pictorial, right? Pictures. So we got tables, we've got graphs, we've got pictures. What else do we have? Algebraic. And then what is the representation that we most commonly have? Thanks, sir. Okay. What was the last one? Verbal. Right? Verbal or using our words is the last one we got. Then we want to write recursive and explicit equations, right? That's the algebraic, is really getting to that point. Can you get 1.7 out so that you can join us? Yeah. Thanks, sir. Alright, so this is what we wrapped up on yesterday. Right? Remember how, and I do want to call your attention to this idea of this table, right? When we looked at this table, none of us wanted to go all the way to 30 days, right? Because we were repeatedly multiplying by 2. But remember what we pointed out or realized was, instead of going by every day, I realized that every 5 days, because it was geometric, what were we multiplying by? Well, we're repeatedly multiplying by 2 every day. But every 5 days, what were we multiplying by? It was 4 to get to here. 1 candy here. Day 6 was 32. So what do we need to multiply by? 32, right? Which makes sense because you just said the common ratio of what we were multiplying by each day was what? So if I do times 2, times 2, times 2, times 2, times 2, how many times am I multiplying by 2? 5. Anyone want to take a shot in the dark? What 2 raised to the 5th is?
6, 4.
Close. Remember, we went from 1 to 32. So it's 32.
Yeah, they're wrong.
What is 2 times 2? Times 2? Times 2? Times 2. Right? So we're repeatedly multiplying by 2 5 times. That's why we could then go every 5 days I was multiplying by 32 here. Things to speed it up. Now I want to point this out here. Which graph is correct? The nonlinear one. Do we agree that this graph is correct and this other one's not? Jeffrey, do you agree with that statement? No? So why do you think this one's correct? Not sure? Okay, well we need to have a conversation about it. You need to understand why. Ladies and gentlemen, if you never understand why, you're not going to be able to do this on your own, which means quizzes and tests are going to be a rough time for you. The discussion of why is the most important part of this. So Alan, do you agree with McKay that this graph is correct and this one is not? Why?
Because it actually does that instead of going completely straight.
So first off, remember, if it is linear, what type of rate of change does that have? Additive, right? An arithmetic sequence which is linear has an additive rate of change. Does this have an additive rate of change? So it should have that curve to it, that multiplicative rate of change. Jeffrey, does that make sense for you? Okay. Tamari, can you please put your mask up? Thank you, sir. So can anyone tell me what is wrong with my graph? Why this one is linear while this one has that correct curve to it? This one is scaling. Well, I mean, this one is scaling, but how did I scale this y-axis? It's getting doubled, right? Whenever you scale an axis, you always need to have what type of rate of change for the scale? 4, 8, 12, 16, 20, 24, 28. What am I repeatedly doing there? Now repeatedly multiplying. 4 to 8 to 12 to 16. Is that adding? When you scale your axes, gentlemen, when we scale our axes, how do we need to do it? Say again? So while I'm teaching, if it's something you don't know, how is it going to help you if you're not paying attention? Come on, guys. We got to be smarter about these things. I'm here to teach you. And then we get upset when we don't know how to do something. I'm not saying just you, but like in general, students get upset with me because they didn't know how to do it. I'm like, I taught it, I was there, I asked questions, I tried to help you. You got to care enough too. Donovan, what do we need to repeatedly do when we scale our axes? We got to have an additive rate of change. You got to have them at axis. Now, we then wrote a recursive and an explicit equation because what we realized is, what are we always doing to the previous value? Multiplying it by 2. And we knew that day 1, Augustus, right, had 1 candy. But then when I look at this explicit here, and I wrote f of d for the number of days, how many candies did he start with? He started with 1 candy, right? And what was he repeatedly doing to that 1 candy?
Doubling.
So multiplying it by 2?
No. Alright, so.
Say again?
He was doubling it, wasn't
Isn't doubling multiplying by 2?
he? Oh,
Is that right?
I think so.
Notice we multiplied by 2 with this recursive equation. So how do we mathematically show repeated multiplication? With that exponent? Why'd I have to do a d minus 1 here, Zay? Say again? You said something about a starting point.
Yeah.
What do you mean by that? Part of it, but notice the starting point is 1 comma 1, which he got 1 candy on what day? On day 1. So I don't need to multiply that 1 by 2, so that's how I balance it out. It's telling me not to multiply by 2 for that 1 day. Notice you could have also written it this way. This is important to recognize. At some point he had 4 candies, didn't he? And he was still multiplying by 2. And so it's going to be an exponent of d, but what would I need to do to that d in order to correctly balance this equation?
Minus 1.
Not minus 1 this time. Minus 3. Donovan, why do you think Zay said minus 3 there?
No.
It is the D.
Yeah, you see 4 candies right here?
Yeah.
What day did that happen on? So he didn't need to multiply by 2 for 3 days. Right? That's the starting output, and you take away that starting input to balance it out. Okay? So we're moving on to a new situation today. Augustus is generally selfish and somewhat unpopular at school. He decides that he can improve his image by sharing his candy with everyone at school. When he has a pile of 100,000 candies, he generously plans to give away 60% of the candies that are in the pile each day. Although Augustus may be earning more candies for doing his homework, he's only giving away candies from the pile that he started with, the 100,000. So, notice I'm just going to create a table here. You can use whatever you want to model this, but it asks how many pieces of candy will be left on day 4 and on day 8. So, when I look at day and I look at candies, before he gives any away, so on day 0, how many candies does he have?
1.
Look at the problem again.
100,000.
Remember, he's giving away after he got that 100,000, right? So he starts off with 100,000 candies. So on day 1, how many candies is he going to have? I thought he gave away,
60%.
he gave away 60% of it. So how much? How'd you get that 40,000? Say again? Not sure? You just knew it. But we need more than just knowing it. Because here's the thing. Legitimately, I'm glad you knew it. But if we can't identify why that's true and be able to extend that, then it might come to bite you in the butt later. He has 100,000 candies. He is giving away what percent? So 60% of 100,000. Does anyone know what mathematical operation is a percent of something? It's not subtracting. Subtraction will be partially involved in this. Let's look to see if anyone notices it under the everyday mathematical language. Do you see, so there's division up there. Do you see a percent of something below the division word? You see under multiplication? Right here? Anytime we say a fraction of something or a percent of something, we're multiplying. Now, I'm not going to write it as 60. What am I going to write that 60% as? 0.6? 0? Now, I want to talk about this just to clarify, make sure we're all in the same boat. Does anyone know why we moved that decimal like that? Or where that decimal came from? It's okay if not, but this will help you in the future. You just know to move that decimal a few times? You just guessed honestly? So let's break down this word. percent. What mathematical operation is connected to per? Good job, Donovan. If you're not sure, look over there. See it under division, bottom left-hand corner? Say again. So it is also under multiplication. It could be both. In this case, we're going to look at it as division divided by cent. How many cents are in a dollar? 100. How many years are in a century? 100. Anyone know how many soldiers were in a centurion for the Romans? Probably 100, right? Cent. It's 100. So it's 60 divided by 100. Now, if I take, 70 and divide by 10, how many times is that going to move the decimal? For 70 divided by 10? It's just going to move it once. Whoops, not 70, 7. What about 55 divided by 10? 5.5 is going to move the decimal once. However, when I look at 100, what times what gives me 100 when thinking about tens? Times? Does that give me 100? 10 times 10 is 100, right? So one of the tens is going to move my decimal once. The second 10 is going to move the decimal one more time. So I just want you to be aware that's why it's moving the decimal twice. It's dividing by those two tens. That should help you in the future with some of these things. But at this point, I will say it's 60% of. We just said a percent of is what mathematical operation? Multiplication by 100,000. Now, some of us may know that off the top of our heads, but if you don't, what's in this classroom to help you out? Calculators, right? So if you need a calculator, I'm totally okay with that. Get it out. Okay, but what is 60% of 100,000? Close. 60% of 100,000 would be 60,000. Notice that's how much he's given away. Now, once he gives away 60,000, how much is he left with? He had 100,000. He gave away 60,000. He's left with 40,000, right? So I want you to notice what he's now going to do is give away 60% of what? Okay? So we need to think about how much candy he's going to have left on day 2. Because notice, if he gave away 60,000 again, would he have any candies? If he gave away 60,000 candies? So we want to think about what that 60% of 40,000 is. So here's my challenge for you. One, I want you to think about how many will be left on day 4 and then finally on day 8. But I also want you to consider and talk about it within your groups. Do you think that this is an arithmetic sequence, or do you think that it is geometric? That's my challenge for you. So be thinking about that, talking about that, doing the work together, helping each other out. I'll be coming around and asking you questions to push on your ideas. Okay, so work together to figure out how many candies